In this episode, we start with a simple idea that turns out to matter everywhere in cybersecurity and operations. A system has to be there when people need it, and it has to have enough strength to handle the work placed on it. New learners sometimes hear availability and capacity management as if they are dry operations terms, but they are really about trust. When a payroll system is down on payday, when an online store freezes during a sale, or when a hospital application slows at the wrong moment, the issue is not abstract at all. It affects people, decisions, money, and sometimes safety. That is why this topic shows up so often in audit, governance, and risk conversations. A dependable environment is not created by accident. It comes from understanding demand, planning for stress, watching for warning signs, and making choices that keep important services running at a level the business can accept. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Systems availability is the ability of a system or service to remain usable and accessible when it is needed. That sounds simple, but there is more to it than whether a server is technically turned on. A system may be powered up and still be unavailable if users cannot log in, if the network path is broken, if the database behind it has failed, or if the application is responding so slowly that normal work becomes impossible. Availability also has a time element. People care about whether a service is ready during the hours that matter to the organization, not just whether it worked at some point during the day. Planned downtime for maintenance is different from unexpected downtime caused by failure, but both still affect the user experience. Good availability management recognizes that the real question is whether the business can rely on the service when it needs to perform important work. That business view is important because availability is never just a technical score. Different systems support different levels of urgency, and that shapes how availability is managed. A streaming music service going offline for 10 minutes is inconvenient, but a payment processing platform failing for the same 10 minutes may create immediate financial loss and reputational damage. A school learning platform might tolerate short interruptions overnight, while a manufacturing control system may need a much tighter expectation during production hours. This is why teams classify systems by criticality. They ask what happens if the system slows, what happens if it stops entirely, how long the organization can cope without it, and what downstream effects appear in other connected services. Once learners understand that availability is tied to business impact, it becomes easier to see why auditors, managers, and operations teams all care deeply about the same question from different angles. Capacity management complements availability by focusing on whether systems have enough resources to meet current and future demand. If availability asks whether the system is there, capacity management asks whether it can carry the load. This includes thinking about processing power, memory, storage, network throughput, and even supporting resources such as staffing or vendor support when those limits affect service quality. Capacity management is not just about buying more technology whenever performance becomes uncomfortable. It is about understanding how much work the system is expected to do, how that demand changes over time, and how much reserve is needed to stay stable during busy periods. A system can be highly available in theory and still disappoint users if it becomes overwhelmed every afternoon. In that sense, capacity management protects availability by making sure services are not only present but also strong enough to perform. The connection between these two ideas becomes clear when you picture a crowded highway. A road may exist and be open, but if too many cars try to use it at the same time, movement slows and may eventually stop. Information systems behave in a similar way. A service may appear healthy until demand spikes beyond what its components can handle, and then the slowdown spreads across the environment. Users experience timeouts, applications struggle to complete transactions, and support teams may first hear vague complaints that something feels wrong before a full outage is declared. That is why smart organizations do not treat availability incidents and capacity issues as separate worlds. Shortages in system resources can trigger availability failures, and repeated slowdowns are often early warnings that capacity planning is behind reality. When teams study both together, They can prevent many incidents instead of reacting only after business disruption is already visible. To manage capacity well, teams need to understand what kind of load a system actually carries. Some workloads are steady and predictable, like a small internal application used at roughly the same level each business day. Others are uneven, such as consumer websites that face sharp traffic peaks during promotions, holidays, or news events. Batch processing jobs may create heavy overnight demand even if daytime use looks calm. Storage growth can be slow for months and then accelerate when a new project begins collecting more data than expected. Network usage may surge when large files are synchronized or when remote access increases. The point is that systems do not fail only because they are badly built. They also struggle when planners misunderstand usage patterns. A beginner should remember that capacity is always tied to behavior. You cannot manage what a system needs unless you first understand how people and processes are actually using it. That need for understanding leads to baselines and forecasts. A baseline is simply a picture of normal behavior over time, and it helps teams recognize when a system is drifting away from expected performance. Without a baseline, every slowdown feels surprising and every resource chart can be misread. Forecasting then takes that normal picture and asks what will happen if the organization grows, if more users are added, if business hours expand, or if a new digital service depends on the same infrastructure. Good forecasting is not fortune-telling. It is disciplined estimation based on trends, planned business activity, and reasonable assumptions about future demand. Capacity management becomes much stronger when it is connected to real organizational plans such as product launches, mergers, academic enrollment cycles, or seasonal buying periods. Systems rarely become overloaded for mysterious reasons. In many cases, the warning signs were visible, but nobody translated business growth into technical demand early enough. Monitoring plays a major role because even strong plans need current visibility. Teams watch measures that help them understand whether systems are approaching unsafe levels, whether response times are changing, and whether resource consumption is climbing faster than expected. The value of monitoring is not in collecting endless data for its own sake. The real value is in spotting patterns early enough to act before users are badly affected. A well-run environment looks for gradual deterioration, unusual spikes, recurring peak periods, and signals that a single component is becoming a choke point for the rest of the service. That may mean one database growing slower under load, one network segment saturating during backups, or one application server handling more requests than intended. Monitoring also supports learning after an incident. It gives teams evidence to compare what they believe the system could handle against what actually happened when real demand arrived. A useful lesson for beginners is that poor performance and unavailability are closely related, but they are not always identical. Many people imagine a system as either working or broken, yet real environments often live in a gray area between those extremes. A payroll site that takes 30 seconds to load may technically still be available, but to the user it may feel nearly unusable. An online form that fails only on the final submission step may seem available until the moment the business process actually matters. This is why mature operations teams pay attention to service quality, not only hard outages. They understand that a slow system can damage productivity and confidence long before a total failure occurs. Capacity management helps here because performance degradation is often the first visible symptom of resources under pressure. If teams treat every slowdown as a minor annoyance rather than a warning, they miss the chance to act while the problem is still manageable. Higher availability often requires design choices that reduce the impact of failure. At a high level, that means avoiding single points of failure, creating paths for work to continue when one component breaks, and planning maintenance in ways that minimize disruption. The exact methods vary across organizations, but the principle is consistent. Do not let one fragile element decide whether a critical business service survives. Redundancy is useful, but it is not magic. Two poorly managed systems can fail together if they share the same weakness, depend on the same power source, or receive the same bad update at the same time. Real availability management therefore combines design, operations, testing, and discipline. It also accepts that no environment is perfectly immune to interruption. The goal is not fantasy-level perfection. The The goal is to reduce likely failures, shorten recovery time, and keep essential services operating at an acceptable level when stress or faults appear. Capacity decisions always involve trade-offs, which is why this topic is linked to governance and risk management rather than being left entirely to technicians. Keeping large reserves of unused capacity can improve confidence, but it also costs money. Running systems with almost no spare room may seem efficient, but it leaves little margin for growth, unusual activity, or component failure. The right answer depends on how important the service is and what disruption would cost the organization. A public safety platform, for example, deserves more protective margin than a low-priority internal reporting tool used occasionally. Capacity planning is therefore a balancing act between economy and resilience. It asks how much headroom is appropriate, how quickly capacity can be expanded if demand changes, and whether the organization is accepting risk knowingly or simply ignoring it. Strong management decisions come from making those trade-offs visible instead of pretending that maximum performance and minimum cost can always coexist. Because these decisions affect the business, communication matters just as much as technology. Availability expectations should be understood by both service providers and business leaders. Otherwise, one group may believe a system is performing acceptably while the other feels repeatedly let down. This is where service targets become helpful because they define what level of uptime, responsiveness, and support the organization expects for a given service. When expectations are vague, teams may celebrate technical success while users still experience operational pain. Clear communication also helps capacity planning because business units often know about upcoming demand changes before operations teams do. A new marketing campaign, a new customer portal, or a new regulatory reporting requirement can all increase system load. If those plans are not shared early, capacity problems become visible only after launch. In practice, good availability and capacity management depend on regular conversation between technical teams, leadership, and the people who rely on the systems each day. From an audit and control perspective, this area is rich with important questions. An auditor is not expected to build the environment, but must understand whether management has a reasonable process for keeping systems available and adequately sized. That means asking whether critical services have defined availability requirements, whether performance and resource trends are monitored, whether incidents are analyzed for capacity causes, and whether planning reflects business growth. It also means looking for evidence that management decisions are documented rather than improvised only when users complain loudly enough. Weak control environments often show the same pattern: limited visibility, unclear ownership, reactive upgrades, and repeated disruptions explained away as bad luck. Stronger environments show planning, review, escalation, and follow-through. For a learner studying this certification, this is a good example of how technical reliability and governance connect. The audit concern is not just whether a system failed yesterday, but whether management is operating a process that makes future failure less likely and less damaging. By the time you put all of this together, systems availability and capacity management stop looking like separate maintenance chores and start looking like a continuous discipline of business support. Availability asks whether services can be relied upon when needed, while capacity management asks whether those services can carry the real workload placed on them today and tomorrow. The two reinforce each other because a system that is present but overloaded is not delivering dependable value, and a system with plenty of resources but poor operational discipline can still fail at the wrong time. For beginners, the key takeaway is that dependable systems come from attention, planning, measurement, and informed decision-making. Organizations that manage this well do not simply hope that important services stay up. They understand demand, build reasonable margin, monitor for change, and connect technical conditions to business impact. That mindset is exactly why this topic matters so much in audit, risk, and day-to-day operational resilience.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.